Okay, hey everyone. I did this in video so that way you wouldn't get behind. So here's your table of contents you need to update. The mutation notes are going to be on page 40. Cell specialization on page 41. I'll give you a second to do that before I flip the page. Okay, we're going to start out talking about genetic variation or variability and mutations. You can basically think of mutations like a typo in the genome. A mutation, by definition, is a change to the DNA nucleotide sequence. It can be harmful, beneficial, or neutral. So we're going to look at an example. Let's say you have a normal DNA sequence, A, C, G, and T. If you had an insertion mutation, you may have the normal A and C with an extra T inserted before the last G and T. Basically, with an insertion, a base is added. With a deletion, you might have the normal A and C, the G is missing, followed by the T. So in a deletion mutation, a base is removed. Then you can have what's called a substitution mutation. You might have the normal A, G, and T, but the C, the second base, is then changed to a G. In a substitution mutation, a base is swapped. All four of these are categorized in two categories: a frame shift or a point mutation. A frame shift mutation is an addition or deletion that causes the rest of the sequence to shift. A point mutation happens in a specific place and does not affect the rest of the strand. So for a frame shift, you would have an insertion or a deletion that's going to shift everything after it. So if you have a base that's added, all the codons that follow it will be changed. Same thing with a deletion. If you delete a base, all of the codons from there on will be changed. A point mutation, on the other hand, only changes that specific base, which then only changes that codon. A frame shift mutation is more harmful because all the codons are affected after it. So let's think about what may cause mutations. You can have natural causes that occur during interphase of the cell cycle. Every time a cell divides, they're going through interphase. So that is a natural cause, because you can have mistakes, just like when you write, like your handwriting, you can make mistakes. So natural causes would occur during the naturally occurring interphase of the cell cycle. Environmental causes would be something outside the cell or organism that causes damage or changes to the code. Some examples of that may be like radiation, chemicals, infectious agents or viruses, and actually extreme heat can cause it as well. Now, impacts. Like I said before, you can have harmful, beneficial, or neutral mutations. A beneficial mutation has a positive effect. It increases an organism's chance of survival. An example of that would be disease resistance. A harmful mutation has a negative effect, and it decreases an organism's chance of survival. So everybody thinks of cancer or any sort of genetic disorder. Neutral mutations do nothing to the organism. It doesn't have a positive or negative effect, and it can still create the same protein. So if you look back at your codon chart, you'll see that some of the amino acids have 3 and 4 different codons that can code for the same amino acid. So if you have only one base that's changed, it may still code for the same amino acid, which then means that it's going to make the same protein. So it will have no effect. Which one of these do you think happens most in the naturally occurring environment? A beneficial, a harmful, or a neutral mutation? Take a second and think about it. So actually, neutral mutations happen more often than any other type of mutation because most of the time we don't even know they happen. We could have a base that swapped out for another base and we would never know the difference because it created the same protein. Versus if it's something that's harmful or beneficial, it's going to show up and it's going to be pretty obvious. That's it for mutations, and I will have another video for cell differentiation.